Let's look at the stretching of a hyperelastic dog bone in the Abaqus Learning Edition. I have the dog bone and I have the gripper displayed here in Abaqus CAE. The gripper is modeled as a meshed rigid body. The rigid body constraint is assigned in the interaction module. The dog bone is flexible, as I said, and it is hyperelastic, and it has the Yo model properties. There are a number of symmetry planes in the dog bone so that I don't have to model the complete geometry. There's a symmetry plane here along this edge and on the underside. I have general contact defined with friction so that the gripper can grip the end of the dog bone. I will do the simulation in 3 implicit dynamic steps, which use the moderate dissipation application. Step 1 is to grip the end of the dog bone. Step 2 maintains all the boundary conditions on the rigid body at their position so that the velocities can die away. And then in the third step, I will do the stretching. I've run this simulation already, and we can look at the results. So here's what it looks like. I'm plotting S11, which is the direct stress along the length of the dog bone. We can see down here in the middle it is uniform. I have an axial connector down in the middle, which allows me to compute the nominal strain by taking the change in the length of the axial connector and dividing that by the initial length of the axial connector. I am outputting the force pulling the rigid body so that I can compute the nominal stress by dividing that force by the original cross-sectional area of the dog bone. Let me show you how that's done. I will save out the history output into the session here. You can see it here. I have the total force pulling the gripper and the connector displacement. I simply have to use the XY data create tool and operate on that data using the combine function. I need to divide the CU1 by the original length, and then the force by the cross-sectional area, which is 2.5, that's a coincidence, times 0.4375, and I'll save that as XY data -1. I can plot my stress strain curve, and there you can see it. Looks nice. Got a little wiggle here caused by the frictional contact. What else can I do? I can, of course, contour plot various things. S11 would be of interest. I can also use tools here in Abaqus CAE to create a display which has the appearance of the full dog bone that we may want to look at. So let me do that. In order to do the mirroring that I need to do, I created a coordinate system down here in the middle so that I can mirror about these coordinate planes to create the effect of the full model. Let me go ahead and do that. That's under View, ODB, Display Options, Mirror Pattern, X, Y, Z planes, apply that. So there you go. I can make this look a little better. Let me tidy this up a little bit by turning off most of the annotations. I do want to keep the legend. I've increased the font to make the legend more readable. So there you go. What else can I do? I can turn off the viewing of the session coordinate system. Should have done that before. I can change the display of the grid lines. I'll turn those off. That's under common options. You can see I'm using these menus. I like to use those. But you can use icons too. So there you go. And one last thing I like to do, and this is a personal preference when I'm making a nice animation, and that is to use the continuous contours. That's under contour options. So that looks really nice. Can animate it, of course. So there you go. Dogbone stretching in the Learning Edition.